Welcome to Geometry Pre-AP, the greatest subject in the world. Today we're going to talk about exploring geometric solids. For the next few units we're going to do, we'll all be dealing with geometric solids. So I'd like you to probably pause this video and write down everything you can think of about geometric solids, about the names of the ones that you know, any parts that they have in them, or any kind of information that you can write, including the formulas that you may have memorized already by now. So pause your video and write down everything you know, and we can see how that relates to everything else that we're going to have to learn for this unit. So we'll pause it, wait about 10 seconds or so. Okay, so hopefully you have a rather extensive list of information, and we're going to see how it relates to all the information I'm going to give you today. So we're going to have a lot of vocabulary in this lesson. So the first piece of vocabulary we have here is the polyhedron. What does a polyhedron mean? And so a polyhedron is a solid that is bounded by polygons called faces that enclose a single region in space. So bounded by polygons is important. It means it's made out of polygons. And those polygons are called the faces of it. They're not called bases, they're called the faces. And so this right here is a polyhedron. This is not a polyhedron because it's not made out of polygons. A circle is not a polygon, so it does not represent a polyhedron. And a lot of people will mix that up. All right, so let's go ahead and get the definition of edge. Hopefully these were some of the words that you had written down. Maybe not polyhedron, but you definitely probably had maybe edge, vertices, or vertex and base. So an edge, a line segment that formed by the intersection of two faces. So if I look at this figure here, we're going to do the edge in red. This right here is the edge. So this is an edge of the polygon. This is also an edge of the polygon. So those are the edges of the polygon. Okay, where two faces connect. So a vertex is a point where three or more edges meet. So we're going to do this in green. And so a vertex would be like here would be a vertex. Here would be a vertex. Vertex are just points. Okay? And so it's just a point where three or more of the edges meet. And finally, the base. Now, the base is the most confusing word in all of polyhedrons and all of geometry because it has so many different meanings. It depends on the context. And here it says, the base of a prism are congruent polygons and parallel planes. A pyramid's base is a polygon. So in this case, with this one up here, we have this, I'll do this in blue. The base of this one is this blue pentagon. That's the base of that pyramid. If you were to look at a prism, let's say like a hexagonal prism, which I'm going to try to draw one here real quick. A lot of people think the base is the bottom. In the case here, the base is, this is the base. So the base for this one is right here. It's congruent to the one on the other end that we can't see all of, and they're parallel, and they create the base. Now I know that this piece right here has a parallel piece in the bottom, but that has a different name. That's called a lateral face, which is a side face. So that right there is going to be your most confusing part. So spend some time really making sure you understand what that one means. All right, just a quick, we'll go over this here. Edges in red. So this is the edges here. Vertices or vertex. Oh, bless me. Are in green. So here are my vertices. I don't see all of them here because I can't see the back side of the figure. And then faces in blue. We have a face here. We have a face here. We have a face here. And finally, the base. Now, the base of this figure, you can't actually see right now. And actually, that's a rectangular prism, so it's very special, which brings me to this right here. The base in a prism is the two congruent parallel polygons. We talked about that before. But in a rectangular prism, any side could represent the base, so you have to watch out for that. That can be really tricky. So watch out when you're dealing with rectangular prisms, okay? All right, and so you might want to take the time to pause the video and do all the edges, vertices, and faces for that triangular pyramid there. And back here, let's see here, I'll turn on my highlighter for a second. The base here could be this piece or any other pieces, but there's one just like it at the bottom that would represent the base also. Okay, so pause video, do the pyramid, mark all the edges, vertices, and faces and base there. All right, so here's some practice I'm going to want you to do. If you have a problem drawing the figures out, that's fine, but you need to at least list. You might want to get to trying to draw these figures out because eventually you're going to have to. So if I look at this first one, is this a polyhedron? Yes, it is. It is a polyhedron because it's made with polygons. What is the shape of the base? In this case, this base is a trapezoid. Base doesn't mean bottom. Base is the congruent parallel polygons. And so this polygon and this one are congruent and they're parallel, and that makes them the bases. This piece right here, A, H, G, B, and E, I, F, C, they're not congruent. They're different shapes, and so therefore that can't be the basis. What are the vertices? Well, A, B, C, E, F, G, H, and I. D is not a vertice. What are the edges? Well, there's a lot. AB is an edge. Remember, these are segments. BC is an edge. EC is an edge. AE is an edge. There's also edges like AH, which are also an edge. So I'm just going to list a few. There are a total of, let's see here, 4, 4, and 4. So that's 12 edges up there. Okay, how many faces are there? In this case here, there are 6 faces. Faces are how many polygons are used to make up this figure. And so there's the bases, which is 2, and then the 4 other rectangles that make up this figure. Okay, so you do the next 2. Pause the video, do those 2. I'm going to talk to you about one of them when you come back to the video again. Okay, so now that you come back, I'm going to not talk about this middle one, but I'm going to talk about the last one. Is this a polyhedron? If not, why? No, it's not. Because the circle base is not a polygon. Remember, it had to be made with polygons. So it says, what is the shape of the base? Well, that doesn't matter anymore because this is not a polyhedron. Okay, so it has no edges. It has really no vertices. The shape of the base is a circle, but that's not a face because this is not a polyhedron. So I wouldn't even really have that. This is its own shape. It's a cone. It has its own little parts and things. All right, so some more about vocabulary. A regular polyhedron, okay? A regular polyhedron, you want to write all these notes down so you have these. All right. I need to delete that there. All right, is a polyhedron where all of its faces are congruent regular polygons. Remember what regular means. That means all sides and all angles are the same, congruent. So a cube would represent a good regular polyhedron, okay? A convex polyhedron. A convex polyhedron, okay, is a polyhedron where any 2 points on its surface can be connected by a segment that lies entirely inside or on the polyhedron. So this is a convex polyhedron here. So you'll want to write down the definition. It's basically a polyhedron that has no holes or pockets going into it. While a concave polyhedron, that's the other type here, and you can see in the picture there, says if any 2 points on the surface can be connected by a segment that goes on the outside of the polyhedron. So that red segment there is on the outside, so therefore this is a concave polyhedron. We will deal with just about any and all types of polyhedrons, but we don't do as many concave, but we do a few here and there. So make sure you know these definitions. You can pause the video anytime so that you can write those down and then restart your video so you can keep going. All right, so there are 5 regular polyhedra, and those 5 polyhedra are called platonic solids based off Plato. And so there are only these 5. There are no other platonic solids besides these. Okay, the reason why these are platonic solids is because of the special relationship that happens. Okay, so match the words with the figures. So we have a spaced figure, and we have different types. So we have polyhedron, and we have not polyhedron. Let's see here. Let's extend my page a little bit. Okay. We have a sphere, which is not a polyhedron. We have a cone, which is not a polyhedron, and a cylinder, which is not a polyhedron. And then we have prisms, and we have pyramids, which are polyhedron. So make sure you know how the hierarchy of these cards are. So prisms and pyramids are polyhedrons. Spheres, cones, and cylinders are not polyhedrons. So they don't have faces, vertices, and edges. So it says tell the number of solids in a polyhedron. Tell what the solids of polyhedrons. So pause the video, put these in the correct place, and see if you got them right. Okay, so now that you start the video, go, this is a polyhedron, this is a polyhedron, this is not, and this is not, because they are with circles and not polygons. Okay, so cross sections is if you cut this as a slice of cheese, you can cut it. What shape would you get after you cut it? And so in this first one here, you can see a little cut, and you can see right here, it's showing you what shape you're going to cut. So that's going to be a triangle. Here we have another cut. You can see the cut right there in the darker colored, which is going to be a rectangle. And finally, if you look at this last one, I'm going to let you do that one. Okay, so pause the video if you need to, write that one down, and have that one in your notes. All right, so write down these. These are 4 more practices, so you can look at each one of those cross sections and tell me what shape is formed. Pause your video, come back to it when you're ready to move on. All right, so tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. So I'm going to let you practice with those right there. Label those in your video. This one's going to have 5 faces. This one's going to have 9 edges. It's going to have 6 vertices. Practice with the other 3. Pause your video, do those 3, and then come back to the video. Now, go back to the problems that you just did in your notes. And so a way to check and see if you got this right is called Euler's theorem. And Euler's theorem basically says that faces plus vertices must equal edges plus 2. So if I look at this figure, this has 1, 2, 3, 4, 5, 6 faces. Its vertices is 4. And its edges is 6. So if I put it in the formula, faces, which is 6, plus vertices, which is 4, equals edges, which is 6, plus 2. Oh, it's not 6 faces. My bad. It's 4 faces. Silly me. So that's 8 is equal to 8. And so that's a way to check. I didn't count those right. It's 1, 2, 3 in the back, and 1 in the bottom is 4. All right, so use that to go back and check your other ones that you just did. So again, check these, make sure you get these right. Make sure you know the names of all these different figures. It's important that you can name each solid and know which types they are. So pause the video, maybe name them, practice drawing them. A net is a 2-dimensional representation of a 3-dimensional solid. So it's when you can take and expand it out into all its different polygons. So that's something that you can work on. We're going to work more on that in the second half of chapter 12. So here's a few things for you to forget. If you ever forget the formula for a figure for surface area, you can draw out the net, and that's where nets help us. They don't really help us for volume, which is what we're going to be doing first. All right, make sure you bring your notes to class, and we'll see you.